Hello everyone, my name is Andrew Jones and I'm one of the LAs for Computer Engineering 331 at Penn State. I want to quickly go over LAB2, explain how to use Mars, and clarify a few of the questions that students often have with this lab. Now the lab doc does a pretty good job explaining the steps for this lab, but I do want to clarify a few things as well as go over the basic usage of Mars. In relation to what version you need, your Mars version can just be the latest. If you're having issues with the Mars windows being too small or the scaling seems really wrong, then you'll want to get Java 9.0 to run Mars. You can download that at this link here. Make sure that you select to download under Java SE Runtime Environment 9. Whatever number is the latest. I think right now it's 9.0.4. You'll need an Oracle account to download this. If you don't have one, you can just use your PSU email to create an account. I'm now going to go over some of the basic usage of Mars, as well as show you how to start creating your programs. So the main interface controls, they're pretty simple. You have new file, open file, save file as. You don't need to worry about these two. These two are for dumping binary data and printing. You have your basic control options, undo, redo, cut, copy, paste, as well as a find. Then you have your controls more related to simulation. You have compile, which after you save your file, you then compile it, and then you can execute your code. This button starts your execution. When you click this, it runs at the speed that you define here. This here runs through one instruction. This here is effectively you just step through an instruction. This here undoes the last instruction, so you can go back one instruction. This button pauses your execution. This button stops execution, so you'll have to restart in order to continue. This here resets your execution to the very beginning. This help icon here shows you all the different instructions that you can write in the Mars interface. You won't need to look at this though, because we provide all the instructions that you will be implementing in the lab doc. This here is the editing interface. It's fairly simple. You have your main editor window. This is where you'll be typing all of your code. You have your list of registers here, and then you have your window here that shows you different messages. Your message window and your register display are more useful during the execution side of things, which we'll talk about now. This here is the execution interface. You can switch through it by the two tabs here. You have edit here and execute here. Here you have your text segment, which is all the assembly code that you will have written. And then below that you have your data segment, which this here shows all of your main memory. Now in the register window here, you can see your 32 general purpose registers, which are all numbered 0 through 32, or 31, sorry. Then you also have your non-general purpose registers, such as your program counter, and then your high and low registers, which are used for things like multiply operations. Down here, you have your message window, which shows you the output of your code. For example, if you call a system call that is to print something, then it'll print it. And it'll also print program is finished running when you call this call to end the program. I now want to go through what the process of using Mars looks like. So when you start up Mars, you'll get a window similar to this. We're going to go ahead and create a new file. And then I'm going to use this icon to save this file. When you click the save icon, you'll be greeted with a window similar to this. I'm going to go ahead and call this code version1.asm and click save. And so now that's saved in the directory that I specified. I'm now going to go through and type all the code in here, which this is from the lab doc. And I'm going to put it into my code here. Okay, now that I've written all my code, I'm going to go ahead and click this icon to save. Now, in order to run this code, I've saved it. Now I need to compile it by clicking this button here. This will automatically open up the execute segment, and it'll show your text segment and your data segment. I'm going to go ahead and click this button to run the program. As you can see, it executes the load immediate instruction here, and then executes the syscall. And that syscall ends the program. I can go ahead and click this icon to restart, and this also resets the registers here. And then I can step through this program to see what's happening at each point. This icon will run one step at a time. As you can see, it highlighted the register that got changed here, which was V0, which got loaded with a value of 10, which is A in hexadecimal. If we want to see these values in decimal instead of hexadecimal, we can check this box here. We can also check this box here to show these addresses here in terms of decimal instead of hexadecimal. And then we can also click this value here to show all the values in ASCII instead of hexadecimal. I've loaded up my version 4 code here because I want to show you how to use breakpoints, as well as a clarification for the third question on the lab doc. I'm going to go ahead and compile. We get our text segment here and our data segment here. I've hidden the registers for now. The lab doc asks you to put a breakpoint at a certain point in your program, specifically at this multiply instruction. We can do that by clicking this box over here. Now that we've added a breakpoint, when we go ahead and run our program, execution will automatically stop at that breakpoint. I have the LAB2 document open here. I wanted to highlight something in question 3. This here is actually a typo. Instead of saying, now execute that one instruction, this should say, now resume execution until it hits the breakpoint again. Basically, instead of executing just one instruction here, we want you to resume execution until it hits the breakpoint again. This is all you really need to know for Lab 2. Just make sure that when you make your submission that you have all 4 of your code versions, as well as your answers, all in a single zip file. If you still have any further questions regarding Lab 2, then I highly recommend that you either come to the office hours of any of the LAs or TAs, or send them an email. Have a great day, and good luck.